Hello, I am doing problem number 2 of homework 8. X and y have a joint density function f of x comma y equaling to a times the absolute value of the quantity x plus y from 0 less than or equal to x less than or equal to the absolute value of y less than or equal to 1 and 0 otherwise. Let us examine the bounds. So right here we have an equation just staring straight at us in the face, y equals to x. Here's the line. However, it's the absolute value of y is greater than or equal to x. So every negative y value equals to a positive x value, which is why I reflected the line of y, the line of everything below the x-axis of the line of y equals to x over the y-axis to give us this. Okay, now you look at the shaded portions, right? So this top shaded portion is very basic. Basically, you take off the absolute value bars and you have 0 less than or equal to x less than or equal to y is less than or equal to 1. So the bounds of y are from x to 1 because y is between x and 1. And the bounds of x, as you can see here, is from 0 to 1. Okay. However, when you multiply this whole equation by -1 to figure out the bounds of y, you get -1 is less than or equal to y is less than or equal to x is less than or equal to 0. I'm going to put -x here and I'll explain why in a little bit. And that's the bounds of y from -1 to -x. This -x is very important because if you just put x there, you will get a completely different answer for a, which I will show you with the double integration to find a. Okay, and the bounds of x are alike from 0 to 1. Okay, now let's move on to part A. Part A, we have here, sorry I did all the work because I wanted to make sure I had enough time for this video. A lot of the work is self-explanatory, except for the beginning, which I will explain, okay? So here, the first part of the integral, you have your unaltered version of y is greater than or equal to x, okay? The bounds of y are from x to 1. The bounds of x are from 0 to 1, okay? We have done this a million times before. I don't want to say a million times, a couple times before. Double integral from 0 to 1, x to 1 of a times the quantity of x plus y dy dx, okay? And so I basically just did the integral out. Take a second to look through it real quick. It goes from here, comes all the way down here, and then goes up here, and this is my a over 2 is my final answer for this first part of the double integral, with where y is greater than or equal to x, okay? Take a moment and just press pause to look at my work. Okay, now for the second part. The second part is a little more difficult. We have the bounds of y are from -1 to -x. Sorry, I would keep forgetting to put that -x. And I want to emphasize this -x because if you just put x there, my final answer for this part also equals to a over 2. It equals to -a over 2, and when you add them both up, it equals to 0, which, you know, we're trying to look for an a, so that doesn't really work out, okay? Just my integral for this part begins right here. Shift that to the middle of the screen for you to see. -a times the quantity of the addition of these two integrals. These two integrals are the integral from -1 to -x, x dy, plus the integral of -1 from -1 to -x, y dy. You can see my work here. Take a moment to pause the video if you need to see my work. Everything here is just, I'm integrating this whole thing. Let me highlight the value of -x. Over here, if you do not use the bounds from -1 to -x, you will just get an x, which eventually, like I said, will yield you the value of -a over 2. And when you add this to the first part, a over 2, you'll get 0. And again, remember, we're looking for an a value. It should not equal to 0. All right, so like I said, take a moment to look through my work. Eventually, I arrive at the point where I figure out all the number values for within the integral except for a. I yield the value of a equals, not a equals, this integral equaling to a over 6. I add it to a over 2, as shown right here. A over 2, sorry, my work is messy. A over 2 plus a over 6 equals to 1. 4a over 6 equals to 1, therefore a equals to 2, okay? And here's my final answer: f of x comma y equals 3/2 times the quantity times the absolute value of the quantity of x plus y. Okay, now here comes a really tricky part. So for part B, we are asked here to find z equals to x and y. We're trying to find little f of z, and we're also trying to draw it. You can see a little of my work here I did. So I looked back at a previous homework to do this problem, okay? So here I have z equals to x, y. So for a graph of z equaling to xy, it would look like this. So it would look like this one, this curve over here, everything under it. We're trying to look for everything under it, and another curve over here. However, we're only really, normally we're interested in what's from 0 to 1. However, for this problem, because we have that absolute value going on, I inflected again the curve over the y-axis so that every negative y value will give us a positive x value no matter what. So for every random variable x times random variable y will be less than or equal to every random variable z. Okay, and I forget which homework this was from. I believe it was homework number 3 or 4, but because yeah, so this is sort of like how I approach this problem. So this first part, for y is greater than 0, I did the double integral from 0 to z of x, 3/2 times the quantity of x plus y dy dx. Here's my algebra. I don't want to call it algebra, my calculus or whatever, my integration. Take a moment to pause the video if you need to look at my integration. So eventually I arrive where this for y greater than 0 equals to 3/2 z minus 3/4 z squared for y is greater than 0. Okay, so now I'm looking for y is less than 0. So, but my bounds are different. My bounds are for x is from 0 to 1, and for y is from negative z over x to 0, because we're looking for some random variable z, negative z over x. So negative z over x equals to y, right? Excuse me, negative y is equal to z over x, and therefore y equals to negative z over x, which is why I have the bounds for y as z over x right here. Okay, and so here is my integration. I'm going to let you take a moment to look at that. Just pause the video if you need to look at my integration. I hope it's clear. It should be clear, very clear. So eventually I actually arrive at the same answer. So 3/2 z minus 3/4 z squared for all y less than or equal to 0. So therefore, for z equals to x of y, sorry, this is okay. This is f of z. Sorry, I didn't specify that before. For all y, and I graphed out f of z for all y. And this is what the graph looks like, and that is the end of the problem. Thank you.